in C. A data type tells the compiler what kind of data a variable can hold. For example, is it a whole number, a decimal, a character, or a text? Without data types, the compiler wouldn't know how much memory to allocate or how to interpret the values. Let's explore all the basic data types in C with examples. Okay, so let us take a look at the categories of data types in C. So C has three main categories of data types. It has the basic data types, which include the int, which are the integers, and another one is the chars for characters. We have even the double. We have the double, okay, like that. And also we have the floats, okay, floats, or you can call them the decimals. Okay, so we have for those are the basic data types in C. We have another category which include which is called the derived data types. Okay, and these ones include arrays, pointers, structures, unions. Okay, and unions and other more. Okay, so we have another category which is the enumeration and void types. Okay, these ones include the enum, the void, and the void. Okay, so in this part we are going to focus on the basic data types, since those are the foundations. Okay, so let us take a look at the first one, which is called the int or integer. Okay, so an integer stores whole numbers like 5, -10, or 200. Okay, so by default, an integer usually takes 4 bytes of memory and can hold values in the range of like starting from 2 billions, 2 billions and something, 2 billions, okay, and something, and less and 2 billions, negative 2 billions, and positive 2 billions, okay, like there, okay, like there on most systems. Okay, so let us take a look at an example. Let us remove all these ones from our code. I'm using VS Code. So let us, to create an integer variable, for example, to create a variable, we use age equals to something, okay, and you assign the value, okay, like that. In other in a programming language like Python, okay. So but in C you have to specify the data type, okay, of that variable, okay, the data type that variable is storing. Okay, so for integers we use int, okay, like that. We use the int keyword when storing variables of integer that stores integer values. Okay, and this one we can now come down here and then we print using the printf function, like that. Printf, then inside here, inside this one, you need to know about the format specifier that you use for integers. So for integers we use %d, okay, for integers. That is the format specifier we use. For example, we use age is going to be equals, then it is going to be right here, so it is going to be there, okay, and we use the format specifier, which is %d, and after there we need to specify our age, okay, our variable age outside those quotes. Okay, so after doing that, let us save, and then we come here in the terminal. I'm using PowerShell. If you want to go in PowerShell, just press PowerShell like that. On Windows, you can, and if you're on Linux, you can use the same command that I'm going to be using. Okay, so from there we are going to use gcc to compile. Then the name of our program, I called it home.c, like that. Then after doing that, you need to specify the output file. We are going to call it home, like that. Okay, so but before I tell you that, let me first remove all of this code. So you need to first confirm if your file is there, okay, in this current directory that we are in. And if I press ls, as you can see, we have the home.c. okay, don't mind about this home.exe. I created it already, but we are going to compile it again. So we are going to use the gcc compiler, gcc home.c / the output is going to be home.exe. And if we press enter, it is going to compile our program into this file, into home.exe, which is an executable. Then from there we are going to press /home. If you're on Linux or Windows PowerShell, just use that one. Okay, so as you can see, we get this output, home age equals to 25. Okay, so that is the output. So we have learned that this is the format specifier that we use, okay, for integers, and we have learned that in order to declare variables that contain integers, we use the int keyword before the name of the variable. okay, like that. Okay, so let us now take a look at the floating point or the float. Okay, so a float is used for decimal numbers like 3.14 or negative 0.5, like that. It usually takes 4 bytes of memory and gives about 6 digits of precision. Okay, so let us take a look at how to use the float points. For example, let us change this to be a pi, like that, pi. Then this pi is going to contain 3.14, like that. Okay, so here we need to remember that we are using float data type. Okay, so like the integers, for integers we use int, and for floating point numbers we use float. Okay, like that, to specify. As you can see here, so here we are getting an error, so let us output our pi using the printf function. And here for floats we use the percentage f, okay, for that as the format specifier, percentage f, like that, and we save. Okay, when we save, we compile our code and then we run it. As you can see, we get this output. Okay, so we can also do something. We can also limit, okay, the number of digits, okay, we want, or we want, for instance, if we want to round off, okay, we can round off to 2 decimal places, like that. So if we save and then we run our program, we compile it and then we run, as you can see, we have limited, okay, the number of decimal places, okay, to 2. Okay, so let us now take a look at doubles. Okay, a double is like a float, okay, but gives double, okay, the precision. Okay, you know, the floats don't have precisions, but the double, the float, the what, like the float. Okay, a double, it is like this. Okay, a double is like a float, okay, but gives double the precision. Okay, it usually takes 8 bytes of memory, but gives about 15 digits of precision. Okay, are you seeing what I'm saying? Okay, I told you for floats, yeah, the floats usually takes 4 bytes of memory and gives about 6 digits of precision. Okay, but for the float, it takes 8 bytes of memory and gives about 15 digits of precision. Okay, so let us take a look at that. So for double, we can have here, let us call it pi again, and here let us for double we use the double keyword. Okay, double keyword, like that. Okay, to format. Then here we can come here and then we give pi, yes, pi. Then here we are going, so for double we use the lf format specifier. Okay, lf format specifier, like that. And if we save and then we compile and run our program, as you can see, we get the same output. So let us try to see if we can round off. As you can see, if we do that and then we save and then we compile and then we run, as you can see, we can do the same. Okay, but for double we have a procedure. It gives us the 15 digits of precision. Okay, so let us now take a look at the char, which stands for character. So a character is used to store a single character like A or Z, okay, like that. So let me show you an example here. Let us have a char. We use the char. For characters, we use char, okay, char keyword. Then here let us give it like the grade, then let us set it to be, so this grade, it can't be outside the quotes, okay, it can't be like that. Okay, so it should be inside the quotes like this, like that. Okay, for Z or for A, like that. Okay, so we can come here, and then we use the format specifier. So for char we use the C format specifier. We use the C, like that, percentage C as the format specifier. Then here we want grade, like that. I want grade to print out grade. Okay, so but you should remember a char is used to store a single character. Okay, and it usually takes 1 byte of memory and stores the characters, or the characters ASCII value. Okay, so if you don't know about ASCII values, try to make research about them. Okay, so and after doing that, let us save and then come here and try to compile our program and then you run. As you can see, we get our A out. Okay, so let us now take a look at the strings. Okay, the string is like another data type, okay, in C, in other programming language, but not in C. Okay, C does not have a separate string type. Okay, instead strings are stored as an array of characters ending with a special null character, which is negative, which is for \0. Okay, so let me show you something here. Let us create our name. Let us create. So we create a string. Okay, a string of characters. Okay, we use the char. Remember, they are characters. Okay, that we are going to convert into a string. Okay, like one word. Okay, but that word is composed of different characters, of many characters. For example, here we can have the name. Okay, so here, as the same way as we create it in the same way as we create characters. Okay, but we use Alice. For example, the name is Alice. Okay, but this one is going to generate an error. Okay, so let us try to output this information and we see if we shall get an error. So here, let us get the name, we save, and then we come here and then we load. As you can see, it has not compiled because we get an error here. As you can see, initializing of char from this one makes integer from pointers without a cast. Okay, so here, as you can see, we get an error. Okay, so in order to remove that error, we use here after the name, we use the square brackets. Okay, we use the square brackets. Let us save and we'll see if we will get an error. In compilation, as you can see, we have not got an error. So if we try to run, as you can see, we get this output. Guys, we get this as my output. As you can see, we get that output. Okay, but in order to get for we need to change this format specifier from char. Okay, and we use s for strings. Okay, like that. So if we save and then we run our program like that, and then we compile and then we run, as you can see, we get Alice out. Okay, get Alice out. Okay, so let us now take a look at modifiers. Okay, and these ones include short, long, unassigned, and the unassigned. Okay, C also allows us to modify data types to change their size or range. Okay, so for example, we can use the short int, and this one is going to contain usually 4 bytes. Okay, 4 bytes. So if we can come here and then we declare our integer, and then we say age is going to be equals to 3, like that, age equals to 3. And here, for example, let us create multiple variables instead of one. So let us name this one to be a, and then let us create another integer, and then we name it b, and then we set it to be equals like 212121. Let us give it 2147 something something, like that. Okay, then after there, let us create another int and we say it to be c, and then we give it like something big, like 44 some 0000 something like that. Okay, so after doing that, we can come here and try to output this information. Okay, so let us change this one. Instead of doing that, let us remove this one. Ctrl Z, let us remove all these ones, and then we change this one because we are going to output integers. Change the format specifier, and the output we are going to specify it later. So before we copy this one, let us break the line for each. Okay, for each output, we move the cursor to the next line. We copy this printf paste. We have 3 variables. So let us change this one to be for a. For a, this one is we are going to output a. This one we're going to output b. This one is going to be c, like that. So after doing that, let us try to output our info. As you can see, if you try to compare, as you can see, we get this one, overflow, as you can see. So this one, overflow in conversion from long int to int, as you can see here. We changes the value, as you can see, we get an error. Okay, we get an error. So we can come here from C, as you can see, C is very long. Okay, so we can come here and we add long. So if we add one long there, and then we try to run, as you can see, we get another error. Okay, so let us try to add another long there. Okay, and then we save. And if we try to compile, let us wait. As you can see, it has run successful. Okay, and if we do that, as you can see, we get our output very well. But this one, you should note that the value has changed. Okay, as you can see, we don't have the precision. Okay, as you can see, we get this one. So let us try to change this one to be unassigned. Let us add unassigned keyword. Okay, and assigned, it is unsigned like that, okay, unsigned int. And if we save and then we run our program, we compile, as you can see, we change it from this one to this one. As you can see, we still get an error, okay. So but let us reduce and then we save, reduce to, and then we run our program, and then we do that. As you can see, we get the precision, we get the values wrong. But let us add one more 0 like that. We compile. As you can see, we get the output, but as you can see, we don't get. So you should consider reading about the info, reading more info, okay, and we should understand these ones, okay, the values that they can hold, okay. So let us change this one. So as you can see, B, we get this value, we get this output, okay, we get this output, okay. But let us add another one, which is like 7. Let us add 7 there, and then we try to compile and run. As you can see, we get an error when we add, okay, we get an error value when we try to add. But let us convert it to be a long like that. So if we run our program and then we do like that, as you can see, we still get an error, okay, as you can see. But here you should note that we get the errors after these values, okay. So as you can see, using the long data type specifiers, yeah, is very error prone, okay. So you should consider learning, okay. As you can see here, if we reduce some values, we get this one, okay. So what you should know about these ones, what you should know about these modifiers is that they allow us to modify data types to change their size or range. Okay, so for example, if we use int, this one will usually be, if we change int to short int, for example, here if we add a short there and then we try to run, as you can see, we get this output. But let us add more values there, and we save, and then we try to compile. As you can see, we get an error, okay, we get error values, okay. But let us try to remove this short like that. Let us remove that short, and then we save. As you can see, we get the correct value, okay. So this one is going to reduce, for the short usually reduce the int to 2 bytes, okay, and makes it to be 2 bytes, okay. So but what if we have our integer there? So we have our long integer here. So the integer at the long, okay, when you use long int, okay, this one is usually 8 bytes long, okay. So, and if you use unassigned int, okay, the unassigned int only stores positive numbers, okay, so doubling the positive range, okay, like that, okay. So let us now take a look at the void, okay, the void data type. Okay, so the void type means no value, okay. It is used in two main ways, okay. The first one is when you are using function, okay, that does not return anything, okay. So for example, here our function is returning a 0, okay. But if we want to remove that one, as you can see, if we remove it and then we save and then we try to compile like that, it's going to compile successful. But as you can see here, ours is int, okay. It must return an integer. If you are using a different compiler, okay, you might get an error. But when we try to use GCC is going to skip that, and it is going to get to know that the return type is going to be an integer. So let me save. There is a time when I tried to compile and it refused, but here, as if they made some modification in the new versions of GCC, as you can see, we don't. It tries to determine the output. But if you want to reduce those errors that might come during production, you can use the void, okay, for functions that don't return any value, okay. So if we do that, it is going to run in the same way. As you can see, it runs in the same way. And another one, when you are using generic pointers, okay, like for instance, if you are using it, you can use it like this, void, and then you use like the pointer, okay, the pointer is going to be there, okay, like that, okay. We shall see this in the next part, okay, in the next part, okay. But let me try to let us you go to the size of a data type, okay. So we can check the size of each data type using the size of operator. Okay, so for instance, let us remove this code, this one here. No, instead of removing, let us come here, and here we are going to get the size. So here we are going to be getting the size of, okay, the size of here. Okay, and for the size, for remember, if we want to get the size, it is going to, we are going to get like the bytes. Okay, the bytes, the number of bytes, and for the bytes we use a format specifier which is LU. Okay, LU. Okay, so let me show you here. LU. Let us have let us delete all of these ones. So let us delete all of these ones, and we are going to use the printf function, and here we are going to get the size of let us we are going to specify. So here it needs to be inside the quotes, then let us here we are going to be using the size of operator, and here we are going to be specifying the size that we want to get, the size of the data type that we want to get. Let us copy everything, paste. Okay, we're going to see what I told you. So we are going to get for the int, for the integers, and here we are going to get for the double, and here we are going to get for the char. Then here let us get for the float. Then here, because they are going to be in form of bytes, we are going to use percentage LU, like that. Then we add, we move the cursor to the next line, we copy. Let us copy this one, go to the next line, we paste it there, and then we paste it there. So let us save. These are going to be in form of bytes. Okay, so let us save, and then we compile. Then we run. As you can see, we get 4814. As you can see, as I told you, double is, it contains 4 bytes. Okay, 4 bytes are allocated. Okay, for the front variables. Okay, and here for the chars, one byte is allocated. Okay, and for the double, as you can see, 8 bytes are allocated, as you can see, and for the integers, 4 bytes are allocated. So if we add here short like that, and we add here let us add for the let us add short there, and if we save, as you can see here, the first, for the integers, 4 bytes are allocated, but I told you that when you use short int, 2 bytes are going to be allocated. So let us run. As you can see, it has reduced to 2. Okay, so if we use long, like that, and we try to run our program, as you can see here, we go to 4. Okay, let us use long like that, and then we try to run. As you can see, we get 8. Okay, we get 8. Let us add another long there. Okay, another long there. As you can see, invalid combination of the try. Okay, so it can be the maximum must be like 2. Okay, 2 longs. Okay, there. Okay, so we can come here, and even here we can we use long float. As you can see, invalid combination of space. Okay, as you can see, specifiers. Okay, so this one, it is not applying on floats. Okay, it is not applying on floats. Okay, so that is it about data types in C.